Suppose a function is derivable, we want to show it's continuous. To be derivable, f prime of a equal limit as x tends to a, f of x minus f of a, x minus a, right and left. Need to show that it's continuous, it means limit as x tends to a of f of x equal to a. So proof, we know that f of x can be written as f of a plus f of x minus f of a. I have added f of a minus f of a, nothing is going to change. Now what I'm going to do, for this f of x minus f of a, I want to divide it by x minus a, not to change anything, I multiply by x minus a. Then I introduce the limit as x tends to a of f of x equal limit as x tends to a of f of a plus limit as x tends to a of this whole expression. Now since I have a product, I can split the limit into two, for this one alone and for this one alone. So it's equal limit as x tends to a of f of a, and this is nothing else than what? F prime of a. And limit as x tends to a of a minus a is 0. 0 times f prime is 0. So we have proved if it is derivable, limit as x tends to a of f of x equal f of a. So if a function is derivable, it's continuous. But the converse is not true. Why? Because here f of x equal x is continuous. Why? Because if you do limit as x tends to 0, for example at 0, 0 left or 0, 0 right, f of x, it is absolute value of 0, which is 0. I don't have any trouble. And f of 0 is what? Also 0. So it's continuous. But is it derivable? No. Because if you apply the property, I'm studying the limit, the derivability at x0. If you do f prime of 0 minus, limit as x tends to 0, 0, f prime of 0 plus, limit as x tends to 0 plus of f of x minus f of 0 over x minus 0. F of 0 here is 0. So it's absolute value of x over x. If inside is positive, if you remove the absolute value, you put x. So x over x is 1. However, if inside is negative, 0 minus, if you remove the absolute value, to be positive, what we need to put before? Minus x, so it's minus 1. So that's why if a function is derivable, it is continuous. But if it is continuous, no need to be at the same time derivable. So derivable at x equal to a, limit must exist, continuity must exist, and limit to the left must be equal limit to the right of the derivative. In other words, we can say f prime of a minus equal f prime of a plus. Places where it's not derivable are asymptotes. If you have, for example, a vertical line like this and then it continue, because derivative of vertical line is undefined. And at points where the derivative, for example, if you have, this is called cusp. So if you do the tangent here, the tangent is vertical. Always at tangent vertical, the derivative does not exist. Okay? Check derivability at the following piecewise function. First of all, before we start, we need to check it's continuous. We don't go directly to the derivative. We check if it's continuous. If it's continuous, we continue. So if you do here at x equal to 2, f of 2 minus and f of 2 plus, here, 2 minus, you're going to get 8 minus 1, 7. 2 plus 16 minus 9 is 7. And f of 2 equal to 7. Limit exists. Now for derivability, instead of doing that, I'm going to do f prime of x. Derivative up is still be 2x plus 2 if x less than 2. It is 8 if x bigger or equal to 2. If you want to do f prime of 2 minus, like I am using this one, so here it is 6, and if you do it f prime of 2 plus, it's 8. So since left is not equal right, so we say it is not derivable. However, this one here, it's continuous. Why? Not continuous. So here if you do 2 minus, so it's 8. 2 minus, it's 10. 2 plus, if you do 2 plus 10, f of 2 is 6. So since it's not continuous, directly it's not derivable. No need to continue. However, if you do here at 0, it's minus 4 equal f of 0, because here you have equal. So it is continuous. If you do the derivative, 3x squared and 2x at 0, f prime of 0 minus equal f prime of 0 plus is 0. So here it is derivable. So always when you have a piecewise function, if you want to check derivability, check continuity always before. Now, derivative of composite function. We know a composite function f rho g of x can be written as f of g of x, and if g of x is denoted by u, it's f of u. Now we want to find the derivative of this composite function. It's the same as finding the derivative of f of u all prime. We know that first of all we have a relation between dy and x, because I have here x, variable is what? X. And f rho g, this whole one is called y. So dy over dx, I have introduced u, so it's the same as dy over du times du over dx. What is dy over du? I want to derive here where the variable is u. Here in this one, derivative of y is y prime, because this is the function, but derivative of u prime is 1. I don't have x here. However, here du over the variable dx, derivative of u is u prime, but derivative of x in the second one is 1. Okay, so if I want to find this derivative, which is f of u prime, it is derivative of y with respect to u. It means derivative of y and f with respect to u. This is f prime of u. And then I want to derive u with respect to x. U with respect to x times u prime of x. So in other words, derivative of composite function, f, derivative of f g of x is nothing else f prime of u, f prime of g of x, g of x is u, times u prime, it means g prime of x. Please, you need to memorize it. So derivative of f of g of x, it's f prime of g of x, you take g of x as u, okay, times u prime, it means g prime of x. So in other words, f g, if you want to find the derivative, it is g prime f prime of g, and if you want to replace it, instead of writing g, you want to write it u. So derivative of f of u, where u is an expression of x, it is u prime, you derive inside the expression inside, times f prime of u. You will understand it now by taking an example. So if you have f of x and g of x, find f rho g of x and g rho f of x. First of all, I need to find f prime of x and g prime of x. So this is 4x and g prime of x is cosine x. I want to find f rho g of x. It means I want to find derivative of f of g prime. So this is f prime of g, don't forget, times g prime. G prime is very easy, cosine x. I want to find f prime of g. G is what? G in this example is sine x. So what do? We go to f prime, that you have it here. You replace x by sine of x. So it will be 4, instead of saying 4x, it will be 4 sine x. So it's 4 cosine x sine x. And if you want to find g of f of x, it is f prime times g prime of f. F prime, we did it here, it's 4x. G prime of f, but what is f? Is 2x squared minus 1. You consider it as u. So you go to g prime, you replace this x by 2x squared minus 1. So it will be cosine 2x squared minus 1. Here the same story. Before we do the composite, derivative of f of x is a 3x squared, x over cosine x u prime v plus v prime u over v squared. I want f of g prime. So what do? First of all, we write g prime. This is the easiest. This is g prime. Then f prime of g. F prime of g. G is what? X over cosine x. I have here f prime. So I go to f prime, I replace this x by x over cosine x. So you're going to get 3 times x over cosine x all squared. And if you want to do the vice versa, so here you do g prime of f times f prime inside f prime. F prime is very simple, 3x squared. G prime times g prime of f. F is x cubed, so g prime of x cubed. So I go to g prime, I replace every x here by x cubed. So you can get what we have. So that's it concerning derivative of composite function.